Hi class, today we'll be tackling lesson number 4 of unit number 2, consumption choice. And for this lesson we'll be covering utility theory as well as consumer surplus. But as always, before we go on to the actual lesson, you want to make sure you look over your homework, take it out, check over your work that you've done, make sure it matches with my answers or the text answers. And just one thing to be aware of in terms of elasticity, elasticity changes individual to individual, or as different individual to individual, as well as over time. And so certain types of things that were perhaps elastic before may not be elastic anymore, and so the datedness of some answers may change depending on who you are or depending on the time period. So any questions that maybe don't fully match with what you're saying, we can have a discussion about it, and please ask and make sure that we are talking about the same ideas and make sure we are understanding things in the same way. And so make sure you check over what's elastic, what's inelastic, what's unitary, as well as be able to explain why something is so. Be able to explain why something becomes more or less elastic or inelastic. Also understanding what the coefficient means, whether it's greater than 1, equal to 1, or less than 1, what that will do to revenues depending on if it's supply elasticity or demand elasticity. Making sure you can calculate the coefficient is quite important as well. So please ensure that you can do all these skills and do all these things before going on to the next lesson. Just check your math here to see that you can calculate supply elasticity. And as an example of what I was talking about for perhaps something that may have changed elasticity over time, think about cell phones. Cell phones in the past may have been a much more elastic item, but nowadays cell phones are very inelastic. So if you break your cell phone, even though it's $1,000, you might right away get a new one, or even just get a used one to temporarily keep you connected while you get a new one for later. So be sure to understand why things change or how they change to understand what elasticity is talking about. So today we're talking about consumption choice. One is to know how to distinguish between marginal and total utility, as well as calculate consumer surplus. Two, be able to apply concepts of marginal and total utility, getting utility maximization. And three, understand what consumer surplus is and how to maximize utility. Success criteria obviously is to review activities and discuss thoughts, as well as completion and review of homework as always. So to start today's lesson, we were going to ask the question, why are diamonds more valuable as a resource than water is? We all understand what diamonds are versus what water is. Water is very life-giving. Water has many more applications than diamonds. Water is something that is a necessity of life, while diamonds are jewelry. You know, there are other industrial things that you can do with diamonds, like diamond cutting, but we all understand how much more valuable water is in the bigger picture than diamonds. Yet, to buy a diamond is much more expensive than to buy water. And so, why is this the case? And so, you're probably going to go over some things like, you know, it's more scarce. So, diamonds are more scarce, although diamonds are not as scarce as you might think. Diamonds can also be manufactured in a lab, so maybe not as scarce as you believe. You might say marketing. So, yes, marketing plays a factor, plays a role. Diamonds have been heavily marketed as an industry, and so that pushes up the value of diamonds for sure. But we want to tackle this question in a much more theoretical method that we'll use to explain utility theory. And so forget about diamonds and water for now. So now think of a product that you enjoy to consume. And so for myself, I'll pick pizza because I like to eat pizza a lot. So think of your favorite food or a food that you eat a lot. It's going to be hamburgers, wings, chips, sushi, whatever it may be. So think of that product. And then on the graph right below, I want you to draw a satisfaction graph. And so let's look at this graph, look at these axes. And so on the x-axis, you're going to see quantity. On the y-axis, you're going to see utility. And when I say utility, I mean satisfaction. So how happy or how satisfied are you with consuming that 1 unit of whatever this thing is? And so if I consume 1 piece of pizza right here, my satisfaction is going to be quite high. Okay? And then how much satisfaction does your second pizza give you? How much satisfaction does your third pizza give you? How much satisfaction does your fifth slice of pizza, 10th slice of pizza, 11th slice of pizza, whatever it give you? So I want you to create this graph and plot your quantities, 1 to whatever, and how much satisfaction they may give you. And so this satisfaction, this unit, is based on you. And so this, use the top of the graph as the most amount of satisfaction that this thing could give you. And so take a moment, try to graph this graph for me, for yourself, to see what it might look like. And so what kind of trends may you be seeing? What kind of patterns do you think are going to emerge when you draw this graph? So pause this video and take a moment to do that. And so hopefully by now you've completed creating a satisfaction graph, and it might look something like this. Okay, and so here let's just not get too caught up with this beginning. So your satisfaction could go up at the beginning. It could be very flat here, but the key point of this graph is that it will decline. Okay, and so let's just dissect this graph a little bit. So when I consume 1 slice of pizza, my satisfaction is right here. When I consume a second slice, it goes up. So it could go up at the very beginning, potentially. It could stay very flat at the very beginning. It could go down right away at the very beginning. But ultimately, what's this graph telling us? It's saying that the more and more and more I consume, the higher the quantity becomes. You know, my 5th slice of pizza, my satisfaction is here. My 8th slice of pizza, my satisfaction is here. You know, my 10th, my 11th, etc., etc. So ultimately, if I keep on consuming or using the same item, my satisfaction goes down to 0. Okay, I'll consume no more of this product because it gives me no more satisfaction. Okay, so I'll consume to this point, theoretically. And so if I ask you the question, ultimately, is there any product, item, service in the world if you use that ultimately, eventually, it's just not, it's going to go down. So they will all go down. Is there a product that won't go down is the question. So I challenge you to maybe think of that. Is there something that you could continue to consume and consume and consume so that it does not go down in this manner? I would suggest that perhaps there isn't. Anything that you consume enough of is going to go down. And so that's not to say that you can't consume more pizza the next day or the next month. So your satisfaction graph can reset. If time goes on, I can go back to my 0 level and start up back again here, right? So, and that time frame for it to reset could be different for different people, different for different products, but ultimately, in one sitting or one situation, it's going to go down eventually, okay, given enough consumption. So understanding that this graph happens, that utility will decline, and I'll clarify that as marginal utility will decline. That's what very, very important to understanding utility theory. And so let's take a look at some of the definitions and some of the theory behind this. So Alfred Marshall, he's the one who thought about utility theory. He is the father of supply and demand as well. And so he's the one who kind of came up with some of these ideas of understanding human behavior and consumption choice. So what is utility? Utility is usefulness or satisfaction. Okay? How useful is something? How satisfied might you be by consuming it? Think about utilities. If you think about your parents paying a utility bill, you know, they're talking about electricity, they're talking about water, gas, those kinds of things, because those things are useful. Those things give you use, or you can use those things in everyday life. They have significant value. So utility is usefulness or satisfaction. 2, one single util is a unit of satisfaction. So how much satisfaction are you going to get out of that singular thing, that one unit of something, okay? Next is marginal. So what does it mean to have marginal or be marginal? The marginal means the extra or more, okay? And so I'm slowly giving you parts of definitions and parts of ideas and words to come up with a singular thing, which is marginal utility. And so if marginal is extra or more, and utility is usefulness or satisfaction, marginal utility is going to be extra satisfaction or more satisfaction. So the satisfaction one gets from consuming or using an additional unit of an item, the next one. So how happy are you when you consume the next unit versus the previous unit, right? So I need to understand if I consume one more slice of pizza, how much satisfaction am I going to get from consuming that next slice of pizza? Right? Everyone, if you're at a buffet, ends up stopping at some point in time, right? You choose to do that because eating more food is not going to make you more satisfied, right? Everyone makes a choice. Regardless of who you are, you've all decided to make a choice at some point in time. So we want to figure out what is our marginal utility for each unit. And so this is in contrast to our total utility. And so we want to look at two of these graphs side by side to see the difference. And so marginal utility we just looked at. It looks like this. As quantity increases, it's eventually going to go down. The satisfaction I get from the next unit is going to get lower and lower and lower and lower and lower, eventually until I hit 0. So that's graphing the individual unit, or the one that is marginal. Okay, that one unit of something gives me that much satisfaction. This one unit, not the accumulation of these units, this one unit will give me that much satisfaction. Okay, again, we're back to our graphing understanding and how to do graphs. So this is in contrast with total utility. Total utility is the accumulation of all the units. Okay, so we are talking about looking at how much satisfaction are you going to get after consuming one, and then after consuming the total of 2 and the total of 3, etc. So one unit gives me this much satisfaction. Having consumed both units gives me this much satisfaction. So I'm accumulating the satisfaction from the one plus the second one, plus the third one, plus the fourth one, plus the fifth one, etc., etc., etc. And so as you see, this graph should flatten off because every consecutive unit is going to give me less and less and less and less utility, and therefore my total utility is going to slowly flatten off. Okay, so this is the difference between marginal and total utility. So it's very important to understand these two differences. So at this time I want to pause, and I want you to flip to page 105, question number 2 in your textbooks. So if you look here, I want you to work on number 2. Copy this diagram or this table into your textbooks or into your notebooks, and I want you to calculate if I consume 0 units, if I consume 1 unit all the way up to 6 units, what's my total utility and what's my marginal utility. So you want to calculate that. So this will help us ensure you have good understanding of what these two concepts are in terms of empirically and how they relate to one another. So just pause and take a moment to do that. So hopefully now you have completed this table, and so I'm going to reveal some of the answers and kind of explain through to ensure that we're all on the same page, that we know what's going on. So if I've consumed 0 units of something, my total utility is 0, of course, and after 0 units, my marginal utility for 1 unit is going to be, or 0 units is going to be 0. Okay? Here, if I consume 1 unit, it tells us our total utility is 6. Why? Because that 1 unit gave us 6 units of marginal utility. And so if I have 6 units plus 0 units, I have 6 total. The next stage told us that that second unit gave us 8 marginal utility. So by consuming that one, this second one, I get 8 more satisfaction. And so I already had 6 satisfaction, so if I go 6 plus 8, my total satisfaction is now 14. Okay? In the same way, this says that after I consume 3 units, my total satisfaction is 24. Okay? And previously, my total satisfaction was 14. And so if I go from 14 to 24, that means my third unit gave me 10 marginal utility. Okay? So hopefully you can see the pattern here. My total utility is the accumulation of the marginal utilities up to that point. So after 4 units, my fourth one gave me 10 more, so now I have 34 total. My fifth one gave me 8 more, so now I have 42 total. My sixth one gave me 6 more, so now I have 48 total. And this is the relationship of marginal utility and total utility and how they work. Total utility being the accumulation of all the utility, and marginal utility is the individual or the extra utility we get from consuming one. So my question here is, when would you stop consuming, right? it seems like a difficult question, maybe, or maybe a very easy question. So, when do you stop consuming? Remember, theoretically, we are all people who want to consume more. We want to satisfy our needs and wants. And so, in reality, we'll try to consume as much as we can until marginal utility gives us zero. As long as I have some satisfaction or usefulness of these units, I'm going to consume. As long as I'm still above zero for utility, I'm going to consume. And so we are utility maximizers. We want to get the most, consume the most, have the most. Does that happen? Can that always happen? The answer is no, because we have limited resources. Remember, we have unlimited wants, but we have scarce resources. Therefore, we all cannot consume everything all the time, right? Some of you have unlimited data on your phones. Some of you have limited data on your phones. Therefore, you cannot consume unlimited amounts of data because you're not, first of all, you have limited resources. You can't pay for unlimited data, so you cannot consume it, or you will not consume it. It's not going to be worth it for you to consume it, right? When we talk about food, I can't keep on consuming more because I can't spend more oftentimes. And so I have to make a choice on what am I going to spend my relatively limited resources on in terms of maximizing my utility. So let's look at an example here. And so I'm going to use pizza and wings because I love pizza and wings. And so we're going to take a look here. So copy out this chart. So pause this video for a moment and copy out the information from the chart. So we have pizzas, quantity of pizzas. We have quantity of wings. We have total utility from consuming those pizzas. We have total utility from consuming those wings. So copy this out. And then once you've copied it out, you'll be able to try to calculate what is our marginal utility. So take that time. So hopefully now you've completely filled this chart out. So my one pizza gave me total utility of 10, and so that one pizza would give us marginal utility of 10. If two pizzas, my total utility is 18, therefore 10 going to 18, there's 8 more, so my second pizza gave me 8. My third pizza gave me 6, my fourth 4, my fifth 2, etc., etc. In the same way, one wing gave me 11, so I got 11. After 2 wings I have 18, therefore the second wing gave me 7. After 3 wings I have 22, therefore that third wing gave me 4, etc., etc., etc. So the question here now is, how many slices of pizza do you eat and how many wings do you eat? So take a minute to think about that. What would you choose? Right? Some of you might choose, I'll eat 2 pizzas and 1 wing. Or I'll eat 4 pizzas and 4 wings, because that's what you just normally do at home. However, in this scenario, we have no restrictions. So your answer should be, I'll have 5 pizzas and 5 wings, because even that 5th wing is still giving me 1 utility right here. Right? So all this stuff matters in terms of you always want to consume, given you have the resources to accomplish that. So now we have to figure out how much to consume. And how much to consume is going to depend on how much money we actually have. And so we need to use what we call the utility maximization formula to look at that scenario. So don't think that this is complex. This is actually quite simple. So just copy this out, take a moment, pause this video, and copy this formula out. So hopefully you copied it out now, and so you can just take some time to listen. This formula is actually telling us the maximum satisfaction you can get per dollar of spending. And so let's look at the rule. This rule is just telling us what do we want to, achieve or look for, right? We want to look for where is our marginal utility of product X. So the marginal utility of product X divided by the price of product X. Where does that equal the marginal utility of product Y divided by the price of product Y? And so this here is telling us how much marginal utility per dollar spend does X give us. And this is saying how much marginal utility per dollar spend does Y give us. And so I look for those statements, right? Because if the marginal utility divided by price of X is greater than the marginal utility divided by price of Y, therefore I should buy more X, because this gives me more satisfaction per dollar spend than this. In the same way, if the marginal utility of product X divided by price is less than the marginal utility divided by price of product Y, I should buy more Y, because every time I buy Y, I'm getting more satisfaction per dollar. And ultimately, if we have limited resources, we want to maximize our satisfaction per dollar. Right? So we can all understand this. And so even thinking about myself, like I like to eat steak quite a bit. So I can go to the Keg and spend, $40 to get, a prime rib or something like that. Or I could go to a fancy steakhouse and spend $150 on a steak, right? I know that the fancy steakhouse, I'm going to get more satisfaction or more utility out of that steak. 100% I know I will. However, is it going to be worth more per dollar spend than going to the Keg? Or even going to the grocery store and buying my own steak for $10 and barbecuing it myself, right? Which one's going to give me more satisfaction per dollar spend? That's how I choose. That's how I should choose, at least, if I'm a rational thinker, right? Because I want to maximize my utility per dollar that I spend. And so our previous scenario for pizza and wings was an incomplete scenario because it only told us the utility that we get. However, we need to understand, what if I have limited amounts of money and pizza costs something and wings cost something? And so now my scenario is going to change. So take a minute now and take a look at this chart. And so you have the same data already, but now instead of calculating margin utility, I want you to calculate margin utility divided by price. Okay? So here we have margin utility for pizza. Here we have margin utility for wings. And you have the price of pizza, and you have the price of wings. So take a minute, pause the video, and calculate the margin utility divided by price. So hopefully you've done that now, and so you should be able to take a look. So if my first pizza costs me $10, and each pizza costs if my first pizza gave me 10 margin utility, but it cost me $2, my margin utility divided by price should be 10 divided by 2. So I have 5. 8 divided by 2 is 4, 6 divided by 2 is 3, 4 divided by 2 is 2, 2 divided by 2 is 1, etc., etc. In the same token, that one wing gave me 11 margin utility, so 11 divided by 1 is 11, 7 divided by 1 is 7, 4 divided by 1 is 4, etc., etc. And so now we have data we can actually use. And so let's remember and recall back to our previous formula. What am I looking for? I'm looking for where margin utility divided by price equals the same thing for the two products I'm considering. Right? So think about this. You actually do this, right? When you go to the cafeteria, when you go to a shopping mall, when you go to a place to consume goods or services, you are doing this calculation in your head, maybe not at this precise way, but you are deciding, okay, do I want this or do I want that? This is going to cost me this is going to cost me that. You're doing these things in your head already. It's just we're putting names to what you think, we're putting prices to and units to what you're actually doing all the time. And so when we look at margin utility divided by price, we want to look at a scenario where what am I going to purchase? And so clearly, with my first wing, I'm getting 11 margin utility divided by price. So this, I get 11 per dollar, whereas the first pizza, I get 5 per dollar. So clearly, spending that $1 is going to get me 11 utility. And so I'm going to buy that first wing. Okay? The second wing gives me 7 utility per dollar. Still more. So I'm going to buy one wing and then another wing first. And now I'll be willing to spend $2 on that first pizza because my marginal utility divided by price is now 5. Right? So I go wing, pizza, and then we get to a point where our utility maximization formula comes into effect, right? We get 4 and 4. So I spend $2 on pizza, that gives me 8. I spend $1 on this wing, and that gives me 4, and therefore I'm equally satisfied with both of those circumstances, both of those decisions. And so given I have enough resources to buy them, I'll buy both. So I consume both, okay? And so we do have enough resources for that. And so my second scenario is my third pizza, which cost me $6, so I get 3 per dollar. My fourth wing cost me $1, and so I also get 3 per dollar. So exactly the same situation. If I have enough resources, I will buy both. And after that, I have 4 marginal utility at $2, so that's 2. And then I have 1 marginal utility at $1 at 1. So therefore, I would buy a pizza in that scenario. And then, lastly, $2 for that last pizza, $1 for that last wing. Therefore, it's marginal utility divided by price at 1 and 1. And so these situations, these red circled bubbles, they're telling us that we're equally satisfied with either of the choices. And so given our resource allocation, given how much resources we have, we will choose to consume both of them if we can. And so what does this mean according to our formula? So our formula says that if we consume 2 pizzas and 3 wings, if we go back to it, 2 pizzas and 3 wings, how much money will we spend? $7. 3 pizzas, 4 wings, we'll spend $10. 5 pizzas, 5 wings, we'll spend $15. And so we're going to remember, we are utility maximizers. Assuming I'm not going to save my money, assuming I'm going to spend all $10, $7 will get me maximization of utility if I only had $7. So that's not an option because I still have money left over. 5 pizza, 5 wings costs me $15. Therefore, I can't buy it. I don't have the resources to do so. And therefore, to maximize utility, I'll buy 3 pizzas and 4 wings, which cost me $10. Okay? So that's how we utilize the utility maximization formula to figure out how much we can spend to get the maximum amount of utility in that scenario. And so you'll be able to tell that in this scenario, our total utility is 49 utils. Okay? So you can try to take that $10 and spend it in any way, and you will not find a situation where you get more than 49 units of utility. So even if we go back to our original graph or original chart, let's go back there now. At 3 pizzas and 4 wings, I get 24 total utility plus 25 utility, so we have 49 units of utility. If you spend $10 on any selection of wings and or pizza, you're not going to get higher than 49. And so that just proves if you use the formula, it'll work. So that in a nutshell is utility theory and how to maximize utility. And so at that point, we're at consumer equilibrium. We have no reason to buy more or buy less. We're using up all of our money and we are happy. And so let's go back to our original question. So hopefully you haven't forgot about it. Why are diamonds more valuable than water, right? So that's what we're trying to answer. Again, we know that water is more useful. We know that it has better applications. Diamonds are more expensive. We pay more money for them. So why is this the case? And so hopefully you can get to the conclusion, and if you think about it long enough, that we want to use utility theory to answer that question. And so understanding that the marginal utility of water is very low because I consume it every day. It's readily supplied. So I'm not super worried about it, right? The total utility of water is high. So I consumed so much of it and I've been very satisfied by it. Marginal utility of diamonds is very high, while the total utility of diamonds is very low. And so what are we using to figure out how much things cost? We're using marginal utility, right? Because we don't have very many diamonds, or we haven't consumed very many diamonds, so I want to spend more. I'm going to get more utility per dollar I spend by buying a diamond. Whereas I'm not going to get very much marginal utility to buy water because I consume it all the time and it's readily available to me. So my marginal utility of diamonds is low, and or water is low. So therefore, my valuation for each of these things is more based on marginal utility than it is on total utility. So if you even think about if you're in the desert and you're dying of thirst, and you have all the ability to carry something, and you see a big diamond there versus a jug of water there, you're more likely to grab the water and keep on walking if you can't pick up both things. Because in that moment, the marginal utility of water is extraordinarily high for you versus having that diamond, right? It's all context based. It's all about in this moment what has more value. Because generally in any specific moment, for us at least in this living in Canada with our resources, our marginal utility of water is very low. Well, if you looked at other parts of the world, it's going to be very, very different, the access to fresh water. And so their marginal utility of water could be much, much higher than ours. And this theory, the paradox of value, is something that actually Adam Smith struggled with. He couldn't understand what seemed like fairly irrational behavior, right? So Adam Smith talks about invisible hand, doing what's best for you, and so he thought that a lot of this was fairly irrational. And so that's the paradox of value. And so that concludes our conversation on utility theory. And so we're going to take a step to look at something called consumer surplus, which is also a consumer consumption theory. So consumer surplus is a concept that often students find a little bit difficult to understand at the very beginning, but becomes much clearer by the end. And so I'm going to make this statement, and you can argue it if you'd like. Almost everything we buy, we are getting a bargain. And so I'll tell you, if you go to the cafe and buy something, you're getting a bargain. If you go to the store to buy something, you're getting a bargain. If you buy gas, you're getting a bargain. If you buy water, you're getting a bargain. Whatever you get, you're getting a bargain. That's my statement, and I'll stand by it. You can oppose it if you'd like, but I'm here to prove to you why it is true. And so we need to look at this in context of what we see as demand. So we have to understand very well what the demand curve looks like and how it behaves and why it looks the way it does. And so I'm just going to create a demand curve that is like this. Everyone has their demand curves. Yours might not be exactly like this, but you have a demand curve that looks similar to this in some form. And so if there is a price of $80, I'll consume one thing. $70, $2, $63, $54, $45, $36. This is a demand curve. It might not be yours, but it is a demand curve, and so we'll use it to illustrate what we're trying to do. So, how much would you spend on item number 1? You'd spend $80. How much would you spend on item number 2? You'd spend $70. Item number 3, $60. Item number 4, $40. Okay, so ultimately, your behavior, as dictated by this demand table, this demand schedule, is going to tell you that on 4 items, if you bought them separately, one at a time, you would spend $260. Okay? Because that's what your demand curve says. Your demand curve says this. Okay? It says that I will buy one at 80. If the price drops to 70, I'll buy another one. If it drops to 60, I'll buy a third one. If it drops to 50, I'll buy a fourth one, etc., etc. So if I buy 4, if businesses can see me, know my behavior, know my demand curve, they'll be able to change prices and lower them based on my behavior. And so I would be willing to spend $260 on these 4 things. Okay? I'm just going off of what the demand schedule is telling me. I'm not trying to feed you false data. This is what the data says. These numbers could be anything that would change this, but it still would be the data. So let's look at what the reality of the world tells us when we have competitive marketplaces. So we're going to graph this demand curve, okay? And so 1, 2, 3, 4, 50, 60, 70, 80. So 1 is here, 2 is there, 3 is there, 4 is there, okay? So this is the demand curve, okay? Ignore supply for right now. So I'm going to go back. I'm just graphing what this schedule tells me to graph. And that schedule is telling me to graph demand like this, okay? And so if demand curve looks like that, my behavior is I will just do what demand says. If price is 80, I buy 1. If price is 50, I'll buy 4. Okay, so that's your behavior. Whatever your graph looks like, your graph will look like this in some form for whatever this product may be. So what does this mean? This means that if I'm willing to spend and buy 4 at $260, if prices can change, what does that mean that if there are competitive markets? In competitive markets, we have a supply curve that intersects our demand curve at equilibrium. And because of the competitive marketplace, in perfect competition, it means that the suppliers are not changing prices. Prices just are set at equilibrium. And so therefore, in reality, if I go to a store and I see prices, how much do I spend to buy these 4 things? At equilibrium, it says I will spend $50 each to buy these 4 things. And so I'm going to spend $200. Whereas in reality, I would have spent $260, but I only end up spending $200. Therefore, I get a bargain. And hence my original statement, on everything we buy, we are getting a bargain. Okay? And so, in reality, I only spend this much money, whereas I would have spent this entire piece, and therefore this, I guess, peach colored triangle is your consumer surplus. And so this spending equals $200, and this consumer surplus equals $60. So hopefully utility theory and consumer surplus are sitting well with you. Please ensure you ask me some questions to make sure that you get these concepts. Thank you.